just like to do a couple of integrals which look a little bit difficult at first sight, but with the right substitution they come out in not too bad a fashion. This is the first of them, and what I'm going to do is let z squared equal the piece under the square root sign, x to the n plus 1. So differentiating, you get 2z dz equals, so that should be x to the n plus 1, is x nx to the n minus 1 dx. And now substituting back into the original integral, we replace dx and x. So this becomes 1 upon n 2z dz over x times x to the n plus 1 times z. And that will then be 2 over n. The z's cancel out. That leaves us with dz over, which should be x to the n minus 1. And that gives us x to the n, which is 2 over n times the integral of dz over z squared minus 1, which we can use partial fractions to solve. That is equal to 1 over n, 1 over z minus 1, minus 1 over z plus 1, dz, which equals 1 upon n, log to base e, z minus 1 over z plus 1, and returning to the old variable, that simply becomes 1 upon n, log to base e, and that would be x to the n plus 1 minus 1 over square root x to the n plus 1 and then plus 1. That completes that one. And there's another one, which is x dx over 1 plus x to the power 4. And here we let u equal x squared. So du is 2x dx. And that means dx is du over 2x. Substituting back into the main integral, we get x du, the x that was there originally, and now replacing the dx, that's du over 2x, and the 1 plus x squared, x to the 4th would be 1 plus u squared. And that is 1/2 du over 1 plus u squared, which is 1/2 of inverse tan u, which is then 1/2 inverse tan of x squared That completes the second of those.